Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the thermodynamic temperature scale. A temperature scale that is independent of the properties of the substances that are used to measure temperature is called a thermodynamic temperature scale. Such a temperature scale offers great convenience in thermodynamic calculations. The second colored principle states that all reversible heat engines have the same thermal efficiency when operating between the same two reservoirs. That is, the efficiency of a reversible engine is independent of the working fluid employed and its properties, the way the cycle is executed, or the type of reversible engine used. Since energy reservoirs are characterized by their temperatures, the thermal efficiencies of reversible heat engines is a function of the reservoir temperatures only. That is, the functional form can be developed with the help of the three reversible heat engines A, B, and C. Applying the former equation to all three engines separately, we obtain an equation. A careful examination of this equation reveals that the left-hand side is a function of T1 and T3, and therefore the right-hand side must also be a function of T1 and T3 only, and not T2. That is, the value of the product on the right-hand side of this equation is independent of the value of T2. This condition will be satisfied only if the function f has the following form. We then conclude several functions satisfy this equation, and the choice is completely arbitrary. Lord Kelvin first proposed taking phi t equals t as to define a thermodynamic temperature scale as. This means the heat transfer ratio can be replaced by the absolute temperature ratio for reversible cycles. This temperature scale is called the Kelvin scale, and the temperatures on this scale is called absolute temperatures. On the Kelvin scale, the temperature ratios depend on the ratios of heat transfer between a reversible heat engine and the reservoirs, and are independent of the physical properties of any substance. On this scale, temperatures vary between 0 and infinity. The thermodynamic temperature scale is not completely defined by equation 357 since it gives us only a ratio of absolute temperatures. We also need to know the magnitude of a Kelvin. The triple point of water is assigned the value 273.16 Kelvin. The magnitude of a cavern is defined as 1/273.16 of this temperature interval between absolute zero and the triple point temperature of water. The magnitudes of temperature units on the Kelvin and Celsius scales are identical. The temperatures on these two scales differ by a constant 273.15. Even though the thermodynamic temperature scale is defined with the help of the reversible heat engines, it is not possible, nor is it practical, to actually operate such an engine to determine numerical values on the absolute temperatures can be measured accurately by other means, such as the constant volume ideal gas thermometer together with extrapolation techniques. Okay, that's all for this task. Thank you very much, and see you next time.